Hello. In this video, we are going to determine the limit of an exponential function. Let us first start with the first limit here. In this limit, we have limit as x approach minus infinity x plus 1 plus 2ex. In order to determine this limit, as we all know, we should first split the limit. It is to find the limit of the first part of the function, limit of x plus 1 as x approach minus infinity. So x plus 1 plus limit as x approach minus infinity of 2ex. So x plus 1 as x approach minus infinity, it is minus infinity, plus limit as x approach minus infinity of 2ex. We have a property that says limit as x approach minus infinity of ex is 0. So 2ex, it will go to 2 times 0. So the answer will be minus infinity plus 0, which is minus infinity. So this is the first limit. Let's go to the second limit. In the second limit, we have the same function, x plus 1 plus 2ex, but in this case, x approach plus infinity. So we are going to do the same thing. We are going first to split the limit. So this will be limit as x approach plus infinity of x plus 1. So this is the first part of the function, plus limit as x approach plus infinity of 2ex. So x plus 1 as x approach plus infinity, obviously it is plus infinity, plus, now what is the limit of ex as x approach plus infinity? We also have this property, limit as x approach plus infinity of ex is going to be plus infinity. So this will be 2 times plus infinity. So this will be plus infinity plus infinity, which is plus infinity. Let's go to part 3. In part 3 we have, or question number 3, we have to find the limit as x approach minus infinity of x squared minus 3x plus 10 minus 7ex. So again, we are going to split the limit. This is the first function and this is the second function. The first part is a polynomial, the second part is the exponential. So this will be limit as x approach minus infinity of x squared minus 3x plus 10 minus limit as x approach minus infinity of 7ex. So this is equal. Now, as I said, the first function is a polynomial. The limit at infinity of a polynomial is the limit of the highest degree term. So let's apply this property here. So this will be limit as x approach minus infinity of x squared minus limit as x approach minus infinity of 7ex. So this will be, so x squared will approach plus infinity as x approach minus infinity. So the first one will be plus infinity minus ex, as I said, will approach 0 as x approach minus infinity. So we get 7 times 0. So the answer will be minus plus infinity minus 0, which is plus infinity. Let us try to find this limit again, but in case x approach plus infinity, what we'll get. So again, we are going to do the same thing. Limit of the first part minus limit of the second part. So this is limit as x approach plus infinity of x squared minus 7x, or sorry, 3x plus 10 minus limit as x approach plus infinity of 7x, which is equal to limit as x approach plus infinity, because this is a polynomial, so we take the highest degree term, x squared, minus limit as x approach plus infinity of 7x. So this will be x squared will go to plus infinity minus 7 ex as x approach plus infinity will be plus infinity. So this will be plus infinity minus 7 times plus infinity is minus infinity. So plus infinity minus infinity, which is an indeterminate form. Indeterminate form. So how to solve this indeterminate form? How to find the answer? In this case, since we have this form plus infinity minus infinity, in order to get rid of this indeterminate form, the rule says in order to find this limit, we should take exponential common factor. If I take exponential, so let me try to find this limit again, but now by taking exponential ex common factor. So if I take ex common factor, we open bracket, so x squared has no exponential in its term, so I should write it as x squared over ex. Minus 3x also has no exponential, so we write 3x over ex plus 10 over ex minus 7. Now let's apply the limit. As x approach plus infinity, ex will approach, this ex will approach plus infinity. So ex will approach plus infinity, multiplied by x squared over ex as x approach plus infinity will be 0 according to the property that says, so let me write the property here. The property says the limit as x approach plus infinity of x power n over ex will be 0 for all n greater than or equal to 0. So that's what we're going to apply here. It means this property says that the limit as x approach plus infinity of any power of x over ex as x approach plus infinity, the answer will be 0. So this means the first term x squared over ex will go to 0, minus 3x over ex similarly will go to 0, plus 10 over ex, so this will be 10 over plus infinity, 10 over plus infinity, which is also 0, minus 7, so we'll get plus infinity multiplied by minus 7, which will be minus infinity. In part 5, we have to determine the limit as x approach minus infinity of x minus 2 plus 3e minus x plus 1. So you know the idea now. We have to split the limit as a first step. Find the limit first as x approach minus infinity of x minus 2 plus limit as x approach minus infinity of 3e minus x plus 1. So the first limit will be minus infinity plus, the second will be limit as x approach minus infinity. First, minus x plus 1 will go to plus infinity, so we get e plus infinity, which is plus infinity, so the answer will be 3 times plus infinity. So we get minus infinity plus infinity, which is again indeterminate form. Indeterminate form. So in order to solve this indeterminate form, we should take exponential common factor. So this will be limit as x approach minus infinity. If I take e minus x plus 1 common factor, we get x over e minus x plus 1 minus 2 over e minus x plus 1 plus 3. Now, as x approach minus infinity, e minus x plus 1 will go to plus infinity, right? So, plus infinity multiplied by. Now, what will be the limit of x over e minus x plus 1? Now, obviously here, this limit, if I try to find this limit aside first, let me show you. If I try to find this limit here, limit as x approach minus infinity of x over e minus x plus 1. So obviously this will be, x will go to minus infinity over, the denominator will go to plus infinity, so minus infinity over plus infinity, it is indeterminate form. Indeterminate form, but this indeterminate form I may apply on it Hopital's rule. Hopital's rule that says I find the limit of as x approach minus infinity of the derivative over the derivative. Derivative of x, it is 1 over the derivative of e minus x plus 1. So what is the derivative of EU? Let me recall here. This is EU. The derivative of EU is u prime EU. Okay, u is a function of x. So this is u. The derivative of u is minus 1 EU, it means e minus x plus 1. Now, what will be this limit? This limit will be e minus x plus 1 will go to plus infinity. We have minus 1 multiplied by plus infinity, it's minus infinity. So we get 1 over minus infinity, which is 0. Okay? Let's go back to our limit. So we get plus infinity outside. Inside we have x over e minus x plus 1 goes to 0. Minus, so here 2 over plus infinity, right? So it is 0 also, plus 3. Okay, so this will be 0 because e minus x plus 1 goes to infinity. So we get, this is equal plus infinity multiplied by 3, which is plus infinity. Let's go to part 6. In part 6 we have same limit but same expression, but x approach to plus infinity. What do we get? So as x approach plus infinity, this will be limit as x approach plus infinity of x minus 2 plus limit as x approach plus infinity of 3e minus x plus 1, which is as x approach plus infinity, x minus 2 will go to plus infinity plus 3 multiplied by e minus infinity. E minus infinity, it will be 0, right? because minus x plus 1 will go to minus infinity as x approach plus infinity. So we get 3e minus infinity, which means 3 times 0. So this is plus infinity plus 0, which is plus infinity. So this was part 6. Let's go now to part 7. What do we have in part 7? In part 7 we have 2x minus 3 multiplied by ex. So in order to find this limit, we have to split the limit as x approach minus infinity multiplied by 2x minus 3 times limit as x approach minus infinity of ex. The first limit goes to minus infinity multiplied by e minus infinity, which is 0, minus infinity times 0, which is an indeterminate form. How to find the solution here? In this case, we should expand the terms here, okay? Because we have 2x minus 3 multiplied by ex. Let us expand these terms. What do we get? This will be limit as x approach minus infinity of 2x ex, okay, minus 3 ex. This will be equal. Now x ex as x approach minus infinity, this is a property. The property says the limit as x approach minus infinity of x n ex is equal to 0 for all n greater than or equal to 0. Okay, so this means the first limit will be 0 minus, here ex approach 0 as x approach minus infinity, so 3 times 0 it will be 0, 0 minus 0 it is 0. Okay, so this is an important property, we should use it. Now notice here that whenever we have infinity times 0, we get an indeterminate form. In order to solve such indeterminate form, we should expand the terms. So here we have ex times 2x minus 3, we expand the terms. Okay, in the previous case, whenever we get minus infinity plus infinity, addition of two infinities, one is minus infinity, the second is plus infinity. In order to solve this issue, we should take the exponential common factor. Okay, so here we should take exponential common factor. Okay, let's go now to part 8. In part 8, the same expression but x approach plus infinity. So limit of the first term x approach plus infinity of 2x minus 3 multiplied by limit as x approach plus infinity of ex. So the first one is plus infinity multiplied by e plus infinity, which is also plus infinity times plus infinity is a plus infinity. Okay, let's go to part 9. In part 9, what do we have? We have limit as x approach minus infinity of the function half x plus 3 minus 2 1 over ex plus 1. So again, split the limit. We have limit as x approach minus infinity of half x plus 3 minus limit as x approach minus infinity of minus 2, or sorry, plus 2 or 1 over ex plus 1. As x approach minus infinity, the first function will go to minus infinity, minus, as x approach minus infinity, we know the exponential will go to 0, so we get 2 over 0 plus 1 so the answer will be minus infinity minus 2, which is minus infinity. Let's go to part 10. In part 10, similar function but x approach plus infinity. What do we get in this case? First we have to split the limit as x approach plus infinity of half x plus 3 minus limit as x approach plus infinity of 2 over ex plus 1. So as x approach plus infinity, the first linear function will go to plus infinity minus the limit as x approach plus infinity of ex is plus infinity, so we get 2 over plus infinity, number over infinity, which is 0, so we get plus infinity. Okay, if we go to part 11, in part 11 we have limit as x approach 0 of e to x minus 1 over x. As x approach 0, in this case we get e0 minus 1 over 0, which is 1 minus 1 over 0, which is 0 over 0. 0 over 0 is an indeterminate form, but we may apply on it Hopital's rule. So applying Hopital's rule in this case, we have limit as x approach 0 of the derivative over the derivative. What will be the derivative of e to x? We said the derivative of eu is u prime eu. So u prime eu. So the derivative of e to x is going to be the derivative of 2x, which is 2 times e to x. So let's apply it here. So we get 2e to x, the derivative of minus 1 is 0, over the derivative of x, which is 1. Now if we apply the limit, we are going to get 2e0, which is 2 times 1, which is 2. So this is the answer. In part 12, we have limit as x approach minus infinity of minus x plus 2 e minus x plus 1. So if we apply the limit here, the limit of the first term, limit as x approach minus infinity of minus x plus 2 multiplied by the limit as x approach minus infinity of e minus x plus 1, which will be equal to, as x approach minus infinity, minus x plus 2 will go to plus infinity. So x is minus infinity times minus, it will be plus infinity, times the limit as x approach minus infinity of e minus x plus 1, so it will be e plus infinity, because minus x plus 1 will go to plus infinity, so e plus infinity, which is plus infinity. So plus infinity times plus infinity, it is plus infinity. The last part, part 13, same function, but in this case x approach plus infinity. So let us apply the limit of the first factor as x approach plus infinity of minus x plus 2 multiplied by the limit as x approach plus infinity of e minus x plus 1. So in this case, this will be equal to the limit as x approach plus infinity of the first factor, it is minus infinity, multiplied by e minus infinity, which is 0, minus infinity times 0, which is indeterminate form. Now, in order to solve this issue here, indeterminate form, we are going to do the following. Since we have negative power for exponential, we should take it to the denominator. We have property that says e minus a, it is 1 over ea. So let us apply this property here. So whenever we have negative power for the exponential and get indeterminate form like here, minus infinity times 0, take exponential to the denominator. What do we get? Limit as x approach plus infinity of minus x plus 2 over e minus into minus x plus 1. So we should multiply the power by negative. This will be limit as x approach plus infinity of minus x plus 2 over e x minus 1. Now, as we apply the limit, the numerator will go to minus infinity over the denominator will go to plus infinity. Minus infinity over plus infinity, again, it's indeterminate form. But this indeterminate form, we may apply on it Hopital's rule. Okay, let us apply Hopital's rule. Hopital's rule says this will be the limit as x approach plus infinity of the derivative over the derivative. The derivative of minus x, it's minus 1. Derivative of 2, it's 0. Over derivative of ex minus 1, it's ex minus 1. Why? Because the derivative of ex minus 1, this is derivative of eu, it says we should derivate u first. It is 1 times eu, ex minus 1, which is ex minus 1. Now, what will be this limit? This limit will be minus 1 over plus infinity, minus 1 over plus infinity, which is 0. So this is our limit. So that's all for now. Thank you and see you in the next video.